In this video we're going to look at impulse. The impulse of a constant force F is defined as F times t, where t is the time for which the force is acting. An impulse changes the velocity of the particle upon which a force acts, and you can calculate the change in velocity using constant acceleration equations and Newton's law. We are going to look at this formula here. You imagine if you've got two bodies and they collide, so one of them goes into the other. That's at the start, and then they move together maybe as one object. Then what happens is this body here puts an impulse, has a force, a certain impulse on this body, and the one in blue has an equal and opposite impulse on the other one. But if they act for if the force they exert, it hits it with a certain force, and it acts for a certain time, you could say here the force times the time is equal to the change in momentum of either of those bodies. So you're looking at one particular body. Okay, so the impulse, say we've got A, the force times time for A is equal to the change in impulse of A, but also you could have looked at B, and the force times the time that it acts is going to be equal to its change in momentum as well. So the formula is Ft is equal to mv minus mu, and you could factorize that to just say Ft is equal to m upon v minus u, and also in vector form, vector force times time is equal to mass times vector v minus vector u. Okay, so this example says a force of 10 newtons acts on a particle of mass 5 kilograms for 3 seconds. The particle is initially at rest. Find the magnitude of the impulse given to the particle by the force. So first of all, you would say impulse is equal to force times time. So it's equal to just 10, and it acts for 3 seconds. So it's equal to 30, and the units of impulse are the same as that of momentum. It's equal to 30 Newton seconds. Now the next thing it says is find the final velocity of the particle. So we don't need to do a diagram. We can just say mv minus mu, and we fill in what we know. So from part 1 we got the impulse was 30, the mass is 5 times your final velocity, minus 5 times your initial velocity, which was 0. So that just tidies up to be 30 equals 5v, a little bit of working out. V works out to be 6 meters per second. Okay, now the next type of question, this type of question, a wee bit trickier, people find a wee bit trickier. It says a ball of mass 15 kilograms collides at right angles with a fixed vertical wall at a velocity of 4 meters per second. The ball rebounds with a velocity of minus 2 meters per second. That just means 2 meters per second in the other direction. Find the magnitude of the impulse exerted by the wall on the ball. Okay, let's make life a wee bit easier. Let's do a wee before. You've got your ball, which is 15 kilograms. It's going towards a wall, hurtling towards a wall at 4 meters per second. There's my wall. And then after diagram, so there's my before and this is my after. The ball is now coming back the other way. So it was -2, so remember that means going back the other way. Ball hasn't changed size, of course. I'll try and keep it similar. Not too bad. 15 meters per second. And there's your wall. And it hasn't moved, it's still the same old wall. Okay. Your impulse is equal to mv minus mu. So I'm going to consider going to the right as positive. So 15 times 2, then minus, and then that 4 is going the other way, so it's minus 4, and then that's going to work out to be just 30 plus 60. So the impulse is 90 Newton seconds, and that's it. Now, just so we know, by Newton's third law, the force and by extension the impulse exerted by the wall is equal in magnitude in the opposite direction of the force exerted by the wall. So the ball will exert an impulse on the wall of 90 Newton seconds. You can just consider the wall to be so vast, that's why it doesn't move. And then the ball moves, the wall exerts an equal and opposite impulse on the ball. Okay, I think it's our last example. It is indeed. A body of mass 10 kilograms is initially moving with a constant velocity of 2I minus 7j meters per second. The body experiences a force of 5I plus 10J for 4 seconds. Find the final velocity of the body in vector form and hence obtain its final speed. Let's just write down your formula. I is equal to, your impulse, vector impulse, is equal to F times vector F times T. And we're going to use an as well. I is equal to mv minus m vector u. So we're just going to fill this in. So your I, vector I then, is going to be equal to the force. And I'm going to use column vectors for this. So what was it? Sorry, where was my force? Where on earth was my force? There's my force there. It was equal to this for 4 seconds. So that's just going to be 4 times 5, 10. Let's just work that out. That's going to be 20, 40. And that's going to be Newton seconds. So then we can fill that in. That's on our left-hand side over here. That's 20, 40 then. And the mass then was 10. Where's my mass? Where am I getting this from? My mass is 10. So 10 times my final velocity, which we don't know. That's what we're trying to find out, of course. Minus 10 times my initial velocity, which is 2 minus 7. So we'll just zoom in on this. That's what we're going to go work with. So that's just going to be 20, 40 equals 10V minus 20, and that would be minus 70. Bring that across the other side then. You're going to have 20, 40 plus 20 minus 70 is equal to 10V. A little bit of working out then. That's just going to be 40 minus 30 is equal to 10V. And then divide across by that then, by the 10, your V then just works out to be 4 minus 3. I would just write my V then as 4I minus 3J meters per second. It says, find the final velocity of the body. We've done that, and hence find the final speed. So again, the speed is just going to be equal to, you can do a diagram if you need to, goes 4 across and then 3 down. There's my speed. So there's my speed, is just the size of that. Or you can just do 4 squared, just do in a bracket, 4 squared plus minus 3 squared, square root of all that, and you will get a lovely answer of 5 meters per second to finish us off. Very good. Excellent. Right, that's our videos all done on momentum. That's the end of those 5 videos. So we've got on, started basic momentum. What else do we do? Conservation momentum, recoil of a gun, objects when they join together after collisions, and then we've got impulse done now as well. Excellent.